Now what happens when you have repeated linear factors? Let's look here. What does that mean? That means x times x plus 1, x plus 1, x plus 1 times x minus 3. So those are repeated, those are repeated. Those are repeated linear factors, or to the first degree. And what is that saying? It says, well, if you have something repeated, you just keep writing it out until you reach that power. So we're going to have a over x plus b over x squared. That takes care of that one. Plus c over x plus 1, d over x plus 1 to the second power, e over x plus 1 to the third power. And that takes care of that, to the first, second, third. And the last thing I have is f over x minus 3. I only have one of those. And no, we're not going to solve that. Just showing you how you could set that particular partial fraction up, and then we would have to solve for those 6 constants. But let's go something a little bit not quite as complicated. So the first thing we need to do is factor the denominator. Well, this is already factored for us, but you want to note that that means x times x minus 2 times x minus 2. So we do have repeated linear factors. So we need to set up our equation. Now how do we set that up? We're going to have x plus 1, our original fraction. What does that equal to? Well, I'm going to have a over x plus b over x squared, c over x minus 2, and d over x minus 2 squared. That one's repeated, that's repeated. The next thing I need to do is multiply the equation by that least common denominator to get rid of the fraction, and that's my original denominator. Right, so when we cancel it out, we're going to have that left-hand side as x plus 1. Then a, one of the x's cancels, but one of them stays. Those x squares cancel, but it leaves me x minus 2 squared. C, I'm going to have x squared times just 1x minus 2, and then d times x squared. I know that's ugly, but just hold on. What do we do next? Well, we're going to let x be our convenient values. The good news is that we have convenient values. So we're going to let that denominator equal to 0. But what happens when I let that one equal to 0? It's the same thing, because it's repeated. And so I only have 2 convenient values, but I have 4 constants. So that's why I'm going to have to do this extra step. But let's do those convenient values first. So I'm going to let x equal to 0. So I have 0 plus 1 equals a times 0, so I'm going to stop right there, plus b times 0 minus 2 squared, plus c times 0 squared, that's not going to matter, and d times 0 squared. So let's do those calculations. So I have 1 equals b times negative 2 squared, that's positive 1/4, so b is 1/4. So I have b. Now I'm going to use my other convenient value. Let x is equal to 2. And again, I'm coming back up here. Everywhere there is an x, I'm going to put in a 2. But I also want to notice that everywhere I have that x minus 2, that's going to become 0. So I'm going to have an a times 0, a b times 0, and a c times 0. And the only thing I'm going to have left is d, and x is 2. Hopefully you're understanding that if I put in 2 for x, 2 minus 2 is 0. That's why that's going to go away. So I have 3 equals 4d. 2 squared is 4. So d is 3/4. So great. I have b and I have d, but how do I find a and c? I need to equate the coefficients. That's going to be the ugly part. So what I'm going to do is I'm going to take this equation and I'm going to expand it, meaning I'm going to multiply all of that out. So I have x plus 1 equals AX, then I'm going to FOIL that out, plus B, going to FOIL the same thing, plus C, so I'm going to distribute that, so I have CX cubed plus, nope, not plus, I believe that's minus 2CX squared, and then I just have DX squared. And now I'm going to distribute here, so I have AX cubed minus 4AX squared plus 4AX. Distribute here. Now I know that's ugly. It's not hard, just takes a little bit of time. So when I say equate coefficients, I'm trying to find A and C. So let's look at the x cubes. Are there any over here? None. What's over here? Just A and C. So what that says is 0x cubed on the left equals ax cubed plus cx cubed on the right. Or in other words, 0 equals a plus c. The bad thing is I don't have a and c. I'm going to put that equation out to the side and just kind of hold on to it. Now let's look at the x squares. Well, do I have any over here? No. But I have them here, 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 and here. And I believe when I copied this further, that should have had a c there. Right, so I have 0x squared on the left minus 4ax squared plus bx squared minus cx squared plus dx squared. Ooh, so I have 0 equals negative 4a plus b minus c plus d. Does that help me at all? Well, I have b and d, so let's put that in. So b is 1/4, c is 3/4. So what does 1/4 plus 3/4 equal? That's 1. So if that's 1, I can put the 1 on the other side. And so I have two equations with a and c. I could actually solve those simultaneously, or I could keep going. It's up to you. Well, let's keep going. Let's go ahead and equate those coefficients. Maybe you're going, I don't know what you mean by solve simultaneously. Well, let's look at the x's. All right, so I have an x here, x there, there, and nowhere else. All right, so let's see what I have. I have 1x equals 4ax minus 4bx. So that's 1 equals 4a minus 4b. But I know that b, what is b? 1/4. So 1 equals 4a minus 1. Add 1 to both sides. And I can solve for a. A is 1/2. Now that I know a is 1/2, I can come back to either this equation and get c. I think I'll use this one. Looks a little bit easier because c then equals to negative 1/2. So I have a, b, c, and d. I'm done. Again, you could go rewrite it into those fractions, make it a little bit prettier, but not necessary. So remember we had a over x plus b over x squared plus c over x minus 2 plus d over x minus 2 squared. Again, you could rewrite those where those come back down here. But again, you could stop at just telling me what those constants are. So why don't you take a minute, pause the video, and see if you could set example number 4 up. Is that your setup? You don't necessarily have a, b, and c over the same ones, but you do need to have an x minus 1 and an x minus 1 squared and an x plus 2 in your denominator. Now what do we do next? We want to multiply through by that least common denominator and cancel out those fractions. Now we want to do our convenient values. So I'm going to let x equal to negative 2. So I have negative 2 squared plus negative 2 equals a times negative 2 minus 1 squared. And the rest are going to be 0, because if I put in negative 2 and I add 2, I get 0. So I get 4 minus 2 equals a times negative 3 squared. So what is that? 2 equals 9a. So a is 2/9. What's my next convenient value? Well, I'm going to let x minus 1 equal to 0. So x is 1. Again, up here we have 1 squared plus 1 equals, let's see, that's going to be 0, that's going to be 0, so I just have c times 1 plus 2. So that's 2 equals c times 3, so c is 2/3. What's the last thing I have to do? Solve for b. I don't have another convenient value, so again I need to equate coefficients. So we can expand that, but before I do, let's see what all b would be involved in. Let's see, you'd multiply that out, and I'd have x squared plus x minus 2 times b. So b is going to be an x squared, an x, or a constant. So we have lots of choices here. So again, if I expand out my equation, okay, remember, once I expand that out, I know that takes a little bit of time, I'm looking for the letter b. So I can choose, since b has an x squared, an x, or constants, you can choose any of them that you want. I think I'm just going to choose my x squares. So if I look at my x squares, here, 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 and that's it. So I have 1x squared equals ax squared plus bx squared. What does that tell you? It tells you that 1 equals a plus b. And you're going, well, how's that going to help? I have a. So b is 7/9. So now I have a, b, and c. Not so hard. And you might be saying, well, could I have used x? Or the coefficient of x? Yes, you could. Could you have used the constants and solved? Yes, you could. I just happened to pick x squared, looked a little bit easier.